This is a GCSE Coordinated Science Chemistry question. It requires knowledge of bonding and useful products from metal ores to complete. Going to recommend you pause, try each section, and when you've done that, review your answers. So here's part A, part B, C and D, E, F, and G. So now if we start our review, substances separated from a mixture using a variety of methods, and we need to pick the right method for the substance and mixture. So if we take a look at ethanol from ethanol and water, where we've got two different liquids and they both have different melting points, we're going to go to fractional distillation. We'll evaporate and then condense them. Salt from seawater, possibly one of the first separation practicals you did way back in year 7, we're looking at crystallisation. Often we'll refer to that as evaporation as well. And the different colours in black ink, hopefully that's directing you towards chromatography. Moving on to part B, where we have got apparatus set up to separate out a mixture by filtering, and we want to know what improvement can be made. Now it's very, very straightforward if you pay attention to the detail of the diagram, because we've currently got a filter paper cone but nothing to support it. So we put that filter paper into a filter funnel. Moving on to part C, and we are using words from the box to complete the sentences. In simple distillation, the mixture is heated to make the liquid evaporate, and the vapour is then cooled to make it condense. And when we are doing distillation, in almost all circumstances it will be evaporation followed by condensation. There are very limited places where it might be we condense and then we evaporate. That's if we're separating gases. Moving on to part D, it's simply a matter of counting the circles and then working out a percentage. So 2 out of 20 are metal B. 2 out of 20 is 10%. Moving on to part E, what do we call a mixture of metals? Straightforward question about whether you've learnt the definition or not. It's an alloy. And moving on again to F, why is the mixture of metals in figure 2 harder than the pure metal? And this has got a very specific answer. It's the fact that the layers are distorted. Now that means that they cannot slide over each other as easily as they otherwise could. And then finally part G, where we are working out the volume of the nanoparticle, which is 20 nanometers by 20 nanometers by 20 nanometers. If you do that calculation, 20 by 20 by 20, we get 8,000 nanometers cubed.